Welcome to this tutorial on Kubernetes Ingress versus Gateway. We'll explore the differences and when to use each. First, let's understand what Ingress is. Ingress is a built-in Kubernetes API that manages external access to services within a cluster, typically HTTP and HTTPS traffic. At the center of our diagram, we have the Kubernetes cluster, which contains all our components. At the bottom of our cluster, we have two applications, App A and App B. These are the services that will receive traffic routed by the Ingress controller. In the middle, we have the Ingress controller. This component processes the Ingress rules and actually implements the traffic routing to the applications. Popular implementations include Nginx, Traefik, and HA proxy Ingress controllers. To the left of the controller, we have the Ingress rules. These define how traffic should be routed, for example, which paths should go to which services. The rules are processed by the Ingress controller to determine where to send traffic. Arrows show the flow of traffic. The Ingress rules connect to the Ingress controller, which then routes traffic to App A and App B based on the defined rules. At the top, we have the Internet, representing external traffic sources. This is where traffic originates before entering our Kubernetes cluster. Traffic flows from the Internet to the Ingress rules, which define how it should be processed by the Ingress controller. In summary, Ingress provides a simple way to manage HTTP and HTTPS traffic routing to services within a Kubernetes cluster. It consists of Ingress rules that define routing policies, an Ingress controller that implements the routing, and applications that receive the traffic. Let's examine the key components of an Ingress setup. The Internet connects to the Ingress rules, which define how traffic should be routed. These rules are processed by the Ingress controller, which directs traffic to the appropriate services. In this example, we have two applications, App A and App B, which receive the routed traffic. Now let's look at Gateway, the newer standard for traffic management in Kubernetes. At the center of our Gateway diagram, we have the Kubernetes cluster, which contains all our components. At the top, we have the Gateway API. This is the newer standard that provides a vendor-neutral interface for defining traffic routing rules. It's more extensible than Ingress and supports multiple protocols including HTTP, TCP, UDP, and TLS. Below the Gateway API, we have the Gateway controller. This component implements the actual traffic routing based on the Gateway API definitions. It's responsible for translating the desired state into actual network configurations. At the center, we have the gateway definition. This specifies the desired state of the gateway, including what listeners are active and how traffic should be routed. This is declarative configuration that defines what you want, not how to achieve it. To the sides, we have routes like HTTP route and TLS route. These define how specific types of traffic should be handled. HTTP route handles HTTP traffic routing, while TLS route handles TLS termination and routing. At the bottom, we have applications A and B, which receive the routed traffic based on the routing rules defined in the route resources. These are the actual services that process the incoming requests. The Gateway API connects to the Gateway Controller, which implements the routing. The Gateway Controller then connects to the Gateway definition, which specifies the desired state of the gateway. Routes connect to the applications, directing traffic based on the routing rules. HTTP route sends traffic to app A, while TLS route sends traffic to app B. At the top left, we have the Internet, representing external traffic sources. This is where traffic originates before entering our Kubernetes cluster. Traffic flows from the Internet to the gateway definition, which then distributes it to the appropriate route resources based on the routing rules. In summary, Gateway provides a more flexible and extensible approach to traffic management than Ingress. It supports multiple protocols, has a clear separation of concerns between API, controller, and definition, and works with various route resources to handle different types of traffic. Let's examine the key components of a gateway setup. The Internet connects to the gateway definition, which specifies the desired state of the gateway. This connects to various route resources like HTTP route and TLS route, which define how specific types of traffic should be handled. The Gateway API provides the interface, and the Gateway Controller implements the actual traffic routing. Applications receive traffic based on the routing rules. Let's compare Ingress and Gateway directly to understand their differences better. Now let's understand when to use each. Use Ingress for simple HTTP/HTTPS routing. Single cloud providers with standard load balancer features and less complex requirements. Use Gateway for multi-protocol support, multi-cluster environments, advanced traffic management, and multi-vendor environments. In summary, use Ingress for simple HTTP routing needs, and Gateway for complex traffic management that requires multi-protocol support, or multi-vendor environments. Both solve traffic routing but at different levels of complexity. Thanks for learning about Kubernetes Ingress versus Gateway. Understanding these concepts will help you choose the right traffic management solution for your Kubernetes clusters.